Hello and welcome back to Math 100. Today we are going to start on chapter 7, which is the chapter on mathematics and fine arts. In particular, we'll be talking about mathematics and perspective in art, mathematics and music, and mathematics and fractals. And this also involves some discussions on what is known as the Fibonacci sequence. All right, so this is an exciting chapter, and since it has to do with beauty, aesthetics, art, and mathematics, we are going to have the virtual background, which is, you guessed it, Venice, Italy. And so from Italy, let's go back to the time of the Renaissance and study the laws or principles of perspective in chapter 7, section 1. All right, let's get going. The topic of section 7.1 is perspective in art and how that relates to mathematics. Okay. What do you mean perspective? I mean, we don't see any numbers. That's right. But as you may already know, mathematics includes geometry, which has a lot to do with perspective and the principles that artists use to draw things that are three-dimensional. So here's the main question. How does mathematics help art or inform or illuminate art? What role does it play in drawing? Okay, and I know we are not going to talk about this, but we live in the days of computer graphics and things like augmented reality, virtual reality, and mixed reality. All of these things have a lot to do with art. And in fact, in the area called linear algebra, which allows you to change perspectives automatically. And so without the modern technology in linear algebra and computation of computations of matrices in computers, it is difficult to imagine today's animation industry. That is how powerful mathematics is and what a significant role mathematics is in playing in the evolution of graphic art. All right, so we start with, well, actually at the end of this section, or in the middle of this section, I'll be showing you some PowerPoint slides just to show you some of the principles I'm trying to indicate or imply in this section. But the main part of this section has to do with these so-called 3 principles of art. Okay, so the principles of perspective. All right, so let's start with number 1. A key to drawing three-dimensional, well, this is not principle 1. A key to drawing three-dimensional objects on the canvas is this thing called projective geometry. All right, and so this is the, of course, one branch of mathematics is geometry, but geometry can be subcategorized. And one area is called projective geometry. Another is transformational geometry. And both of these have a lot to do with today's art and computer art in particular. Now, this began in the, of course, the Greeks, of course, had, some ideas of perspective, but the whole real serious study of perspective began in the Renaissance. So this started in what country? What country gave birth to the age which today is called the Renaissance, right? Florence and other cities in Italy, okay? And so because of the all the wealth that was generated by the Medici family in Florence, they were able to commission artists, right? And many of the Renaissance artists were actually working for the Medici family, which made a lot of money from the Pope and his church and the government, right? So the principles of perspective. This is what I'd like to talk about. And by the way, this is all based on this whole idea called the visual. The actual object is drawn by visual pyramid. I drew a picture of this, so you may want to draw this picture on your notes as well. So it's called the visual pyramid because right here is the artist's eye. And so this eye is looking at the objects over here and expecting to draw that on this piece of paper on your drawing book or sketchbook or the canvas. I'll be referring to this piece of paper or the plane called by the word canvas, but it's basically any flat plane on which the three-dimensional objects are projected. Right. So the eye is at the apex or the vertex of this virtual or the visual pyramid. Right. So whose apex is the eye. All right. So I am going to give you a disclaimer because I am not an artist nor a son of an artist. All right. My wife is an artist and she's a fine artist. She does watercolors and oil and drawing and things that I couldn't even imagine, lithographs and so on. So I am just going to just try to illustrate this. All right, let's draw a little vase here. That's not too bad, actually. All right, let's say you have a little plant in this room, okay? And then you have maybe a picture frame, maybe a little drawers or something, something that is like a furniture. Okay, so if these objects are here, maybe this sticks out like this. What happens is if that person from that position is trying to draw this, everything gets projected, right, along the straight line like this. And so the object here, the picture on the wall would look like this. And then you have the plant, the vase that comes out like this. And of course, your drawers, the set of drawers will look something like this, right? But it's all based on the line from each of these points to the eye through that canvas, okay? And whatever this point is, the point of intersection of this line and the canvas is where that point is projected. Okay. And actually, the virtual reality and augmented reality, all of these computer-based, geometry or the reality kind of things are based on this very idea of a pyramid or the visual pyramid, right? And they study the coordinates on this plane called the canvas. And what happens if you move the eye, if you rotate the canvas, they do all that transformation by using what is called matrices. These are the array of numbers in mathematics. All right, so mathematics plays a huge role. Ask an animation professor, ask an art professor, and they will tell you that mathematics plays no minor role in pretty much any aspect of art. Okay. All right, all parallel philosophers will tell you that there is an aspect of mathematics which has to do with beauty and aesthetics. And so maybe mathematics itself may be an art form. All right, so here are the three perspective laws or principles, right? Principles of perspective. Number one, actually, I should number these, okay? Number one, all parallel lines parallel to the canvas remain parallel to one another, okay? And I will illustrate this point by in just a minute. Let me give you the second and the third. This is number two. The second law of perspective is actual parallel lines perpendicular, this is the key word here, perpendicular to the canvas. Okay, the first ones are parallel to the canvas, but all parallel lines perpendicular to the canvas will not remain parallel, but they merge or converge at the principal vanishing point, PVP. If you are an art student, you may be very familiar with this, the idea of perspective, right? Number three, then you have an advantage over your classmate if you are already familiar with drawing of three-dimensional objects onto a two-dimensional canvas. All right, number three, all other parallel lines that are not parallel to the canvas or perpendicular to the canvas, they also merge, but not at the principal vanishing point, but some point. These are some other vanishing points, but all of those points are going to be on this line called HL, which is what? Horizon line, HL, or sometimes called the EL, the eye level. Okay, so now let me demonstrate, and I'm going to use different colors here today because it's hard to tell you all these things without showing any colors. Okay, number one, which lines are parallel to the canvas and therefore parallel to each other? All right, let's use blue. Okay, so these lines, oh, that's not the right one here. Let's erase this. Okay, I have blue lines. Yep, that's good. All right, so this line, maybe I'm going to just use, yeah, this is good. Okay. This line here, that's blue. This line, all of these edges are parallel to each other, and they are parallel to the canvas, right? If you know what I mean, this line and this line here, this line here, this vertical line, all of these vertical lines are not only vertical, but they're all perpendicular, sorry, all parallel to the canvas. And so all of these are going to remain parallel to each other. Like, this line is parallel to that, which is parallel to this and this. All the horizontal lines are still parallel. They don't meet. And then all the vertical angles, lines are parallel to each other as well. Okay, same thing here. These vertical lines are going to be parallel and they will remain parallel. This line, this line, this line, same thing. Okay, so these are all the lines parallel to the canvas and they will remain parallel to each other. Oh, okay, let's use orange for this set of lines perpendicular to the canvas. So now notice this line here, this line, and this line. These orange lines are perpendicular to the canvas. This is a line that's going away from the canvas, right? Same thing here, same thing here, same thing here. And in fact, this is also going away from the canvas. This is going away from the canvas. All of these orange lines are perpendicular to the canvas. And you can tell they all meet at this one single point. All of these lines here meet at this one single point. That point is called the principal vanishing point. Okay, every picture should have a principal vanishing point if it is drawn to perspective. I'm not talking about drawing like of Picasso's Cubism paintings. That's weird. I understand that there are this artistic value, but I'm not talking about this. All right. So if you draw pictures to perspective, you have a principal vanishing point where all the lines perpendicular to the canvas in real life will converge. Okay. Now, number 3, there are other parallel lines. They are not perpendicular to the canvas, nor are they parallel to the canvas, but those other parallel lines merge at some other points. Okay, so these, let me use light turquoise color here. Okay, so for instance, and it's hard to see this, but this line here, and this line, and this line, all of these lines are not perpendicular. These are not perpendicular to the canvas, nor are they parallel to the canvas, but they all meet at this point. That is not the principal vanishing point, but that is a vanishing point. Okay, same thing with this line, this line, this line. All right, these lines are not parallel to the canvas, nor perpendicular to the canvas. Okay, they're sort of like lateral at an angle, but they all merge. If they're parallel to each other, they all merge at this one single point, which is a vanishing point. Okay, the idea is, and this is an interesting part, all of these vanishing points are going to be located on one horizontal line on which you also have the principal vanishing point, and that is the line representing the eye level, otherwise known as the horizon line. Okay, and same thing here. This is a horizon line. In this case, the objects are on top of the horizon line because your eye level is lower. Over here, the horizon level is higher because you're standing up maybe, and your objects are below you. Okay, so that's how you draw these pictures according to the principles of perspective. Now, this is maybe harder said than done, because if you draw a picture like this, now go ahead and this is your practice, right? And I have already used the features available to me through the Microsoft Surface, all of these tools in the toolbox. That makes it much easier for me to draw something like this. But try to draw something like that, okay? And you will actually have homework problems and quiz problems where you would have to do something like this. All right, so what am I doing here? This is a tiled floor. And I made it so that the width is all the same. So this, these are all like 1 inch, okay, which makes it easier for you to figure this out, okay. And in order to, so I draw this line here, this horizontal line, okay, and then I draw all of these lateral lines. So notice here, in my picture, each tile is a square, okay, and so I draw all the diagonals. And because each of them is a square, the diagonal lines will merge at this point, the point which is called a vanishing point, right? All these other lines going away to the other one, this will also, this, I didn't draw this to the end, but this will all merge at another vanishing point. Vanishing point 1, vanishing point 2, and many other vanishing points exist, but this is the principal vanishing point. Okay, and if these lines, by the way, dictate where the horizontal lines will go. So you notice here, this length is longer than this length, which is longer than this length, right? But the thing is, what I'm drawing is the same tiles over and over again. Why is this line shorter than this line? Well, because that's farther away, right? How do you know what this length should be based on this length? Well, the position of this horizontal line is dictated by where these lines intersect with these green lines here and the purple lines. Okay, so try to practice this and make sure that you can get all of these points to intersect at the appropriate place. Okay, it's, again, it's not so simple, and you have to be very careful when you draw this kind of picture. All right, now I'm going to show you some examples using the PowerPoint, but before I go further into this, I want to tell you probably the most famous example of a picture, or maybe the artist using these principles of perspective, sometimes properly and sometimes intentionally in a sort of a weird way, is Leonardo da Vinci. Okay, so here is Da Vinci's classic. You know that, can you recognize this picture? Do you recognize this picture here? It's called the, yeah, it's a famous painting, The Last Supper, and it is by Leonardo da Vinci. So, I don't know if I should capitalize that DA, but anyway, and of course he is probably the most famous of all of those Renaissance artists. Okay, he also was an engineer and a scientist and everything else, so it's hard to just call him an artist, but he's definitely an artist, famous for his Mona Lisa and this one here, Last Supper. Okay, now why is this such an important example? Well, you can tell that these lines, I hate to kind of mess somebody's, masterpiece, but if you have this line here, okay, you see what I'm doing here? This is the line going along the top edge of these paintings or wall pictures or something. So, and then all of these lines on the ceiling, they all merge at the principal vanishing point, which is exactly where the head of Christ figure is located, right? So the point is, and again, if you are if you're a student of photography or art, you know that this principle of vanishing point is naturally the point where our eyes are drawn to. So you put your focus on that principle of vanishing point. And so that is an example of a classic art piece that utilizes the principles of perspective. Okay. Now there are other, many examples, and this is of course a very recent example. And you can see these lines here, moving, all merging toward this one spot, which is a principal vanishing point. If you connect the lower edges of these windows, of course, they all have to merge all at the same point because all of these lines are perpendicular to the canvas. Okay, and again, the artist is trying to put the focus or the main subject of the art piece at that principal vanishing point. All right. Okay, we'll talk about Escher and the British artist Julian beaver in a moment. Let me switch my screen to show you these pictures.